Okay, so basically what we're doing today is we are covering research methods. So research methods is a huge chapter in your book. It's also a huge PowerPoint, but what we're covering today is not going to be super extensive. It's just going to be the basics. And it's basically all about, because obviously psychology is a science, so we're trying to learn about, okay, what are the different methods? What are the different basic concepts around conducting psychological research? Okay, so what are the things that psychologists and researchers and experimenters do when they conduct psychological research? How do they choose participants? How do they collect data? How do they analyze that data? And basically, how do they then publish that research as well? So that's all we're really doing today. So just going through a few of the basic concepts for research methods. And if you looked at our class page, you'd realize that we are actually covering this topic next week as well. So it's that big of a topic that we do need a full 2 weeks to kind of cover it properly. Okay, I do want to cover it properly and not just do a recap, because you guys, this is the first time you're actually going to be beginning this topic. Okay, so we've got to cover it well. One of the reasons for that is that research methods is one of the main topics that is actually covered next year as well. Okay, before you have like a heart attack looking at this list of learning activity questions, obviously, like I said, it's a big chapter in your book. It's a big chapter as well. So we do have learning activities going all the way up to 2.27 or 2.29. Now, how you're going to read this learning activity checklist is, I know a very small number of you have the old textbook, but I don't want you guys to be like super confused. So what I've done is I've just put the learning activity there and what textbooks it corresponds to. If you look at this list here, you'll realize that a lot of the activities are the same, but in certain learning activities, the questions might slightly differ. Like if you look at 2.16, questions 1 and 4 actually become 1 and 5 in the new textbook. Okay, so it just depends, just whatever book you have, just look at that specific column. And some of the numbers change towards the end. So 2.26 in the old book is actually 2.27 in the new book. So as long as you just look at this list and just match it up to which book you have, you should be fine. So just follow those questions. So like I was saying, research methods is a really big chapter because it covers all the knowledge and key skills. Now, if you've looked at your study design, you'll realize that in your study design, you've got a section that's called VCA's Key Science Skills. Okay, and for each of your sciences in VCE, you've got those skills that are happening. So obviously, these key science skills that we're going to go through in this chapter 2, research methods, is relevant for units 1 to 4. So you learn it this year and you're going to use it for next year as well. It's literally the exact same topics you cover again next year. It's just that next year we focus a lot more on doing the exam style questions, whereas this year it's more about basic application of these concepts and basic like learning the definitions, learning the examples. Okay, so if you really want to do excellently or score really highly next year, it is essential that you have a good understanding of this topic. This topic isn't always the most interesting topic, I will admit that much, but it is one of those topics that you have to learn to like, or you have to learn to at least deal with, because it is one of those topics that a lot of students do lose marks on in unit 3 and 4. Okay, now obviously this checklist of learning activities, I've already uploaded it under the week 5 tile. So if you go under week 5 tile, it is there as a Word document. So you can actually download that, or you can just take a snippet of it from this PowerPoint, which has also been uploaded to the week 5 tile. All the questions on this checklist are not due this Friday as per usual. They'll be due next Friday. Okay, try to get them done by next Friday, because obviously, you know, after next Friday we've got Eid on that weekend and you don't want to be doing learning activities on Eid or even thinking about doing homework on Eid. Okay, so just try to get it done by Friday. If you just do it as we go along in the offline sessions and stuff, you should be able to get it done. There's not that many questions. All right, so having said that, we'll just get started. So obviously when psychological researchers or experimenters or scientists, when they actually conduct experiments, they need a bunch of people to conduct experiments with. And so how they actually select this bunch of people is by a process called obtaining a sample, okay? A sample is a specific group of people that the experimenter or researcher will select from the population to conduct their research study, or to be involved in their research study. In other words, our sample is the participants in the actual study, okay? The participants that are actually doing the tasks, the participants that are actually being tested in that study. The population is the larger group of people from where we draw the sample. So if you look at these little diagrams here on the side, you'll notice the population is the big orange triangle, and the little purple triangle inside is this sample. So the sample is always within the population. It's like a subset of the population. Okay, if you look at this diagram of like ants here, the population is all these ants here, these, you know, these lots of like high number of ants, and the sample is basically the 9 ants that we obtain from the population. So remember, samples are not just drawn from nowhere, they're always drawn from an actual population, okay? If I am going to be, you know, if I'm going to conduct a study, I'm a researcher, let's say I'm going to conduct a study on the effect of early bedtimes on VCE students at Altaqua College. VCE students is the population, but if I then decide that, hey, specifically I want to focus on psychology students, I might then take psychology students and they become my sample, because the actual population was Altaqua VCE students in general, and the sample is something I'm taking from that population. So specifically VCE psychology students, or specifically VCE biology students, or specifically VCE English students. So the sample is always derived from the population. And one of the reasons the sample has to be taken from the population is because if our results turn out to be really reliable and really good and strong results, I can then make a generalization to the population. So if I conduct that study on the effect of early bedtimes on VCE psychology students, and it turns out that my results come out in the sense that VCE psychology students who sleep early will have better SAC marks because they're concentrating better in class, I can then take that result and I can then say that, okay, this applied to VCE psychology students, but I can actually generalize these results or apply these results to all all VCE students in Altaqua, regardless of what subject they do, okay? So that's the reason why we always take the sample out of the population, because whatever results we do get for the sample, we can then apply that or relate that back to the broader population. Okay, so that's basically what the sample and the population are in terms of research in psychology. Then we look at something else, and you might have learned about this probably in like science, like in year 10 or year 11. But basically, when we're looking at a research hypothesis is simply a testable prediction. It's a prediction that the experimenter or researcher or scientist makes about what they think their study will achieve, okay? And usually a research hypothesis will contain the following features, and we use the memory tip iPod to remember them. So the first thing a research hypothesis almost always includes is an independent variable. You might have come across this in science again, when you do experiments and pracs. So independent variable is your IV. Then you come across your population, okay? The population is basically your broader group of people from which you drew a sample. Operationalized variables, I'll talk about what these mean very soon, but these are just more making IV and DV more specific, so explaining how they're measured. And lastly, you're stating the DV, okay? We're gonna look at an example of a research hypothesis, so this might seem a little abstract right now. Now, a research hypothesis is important for us to know because it's important for us to understand that if you don't have a testable prediction and you don't have a clear testable kind of prediction written in words, it's not going to give the researcher any direction as to where they're going with their study. So this research hypothesis kind of like acts as an objective, and the researcher can keep looking back at it and say, okay, this is what my study aimed to achieve. So this is what I need to, this is how I need to set up my study, or these are the tasks that I can do in order to achieve that. Okay, so we're going to learn more about IV and DV very soon. Just the one thing I want to point out here in this slide here is that, okay, we learned about samples and populations on the other slide. I told you that samples are the actual people that are in the study. So then why are we only talking about population in the hypothesis? Well, the reason for that is that research hypotheses are never written specifically for the people in the study, okay? When we write a research hypothesis, we want to generalize, we want to be able to generalize that back to the population, okay? And a lot of the time, if our results do come out nice and strong and reliable and valid, we don't often say that, hey, these are good results for the sample. We actually say that these are good results because we can apply them to the population. So remember, research hypotheses are always applied at the population level, not the sample level. So that's why we've got a mention there of population, okay, not sample. All right, so when we're talking about experimental research, so what is an experiment? Well, an experiment is basically a kind of method that we use to understand how things work, okay, in general terms. Usually the two main key features of an experiment is, number one, they usually test or assess a cause-effect relationship, okay? So there's a cause and there's an effect. And in psychology or in most science subjects, we refer to the cause as being the independent variable and the effect is the dependent variable. And that cause-effect relationship is usually assessed or tested under controlled conditions. So controlled conditions means we usually run experiments in a lab, or we can run them in a classroom, or we might run them in a university. Okay, we might run them somewhere where the researcher has full control over what's happening. A lot of the time, we won't run like a proper structured experiment in the middle of an AFL grand final game, okay? We're not gonna do that because we don't have control over what happens in that environment, okay? It's really erratic, it's really unpredictable. So a lot of the time, researchers or scientists will run experiments in controlled conditions, usually in laboratories, but also in like any other environment where they can control the variables as much as they can. So obviously, like I said, in an experiment, there are two variables. So one represents cause, that's the IV or the independent variable. The other variable represents effect, and that's the dependent variable, that's the DV. Now, the basic idea behind all experiments is that when we manipulate one variable, when we manipulate or change the IV, this will cause or produce some effect in the DV, okay? So let's look at an example. So if I'm doing an experiment on the effect of being sleep deprived on academic performance, and I tell you guys, okay, you're my psychology class, so you guys are going to be my participants in this study. And I said, okay, I want everyone to go home and to, you know, be sleep deprived. So maybe on the first day I might be like, okay, guys, I want you to be sleep deprived for 2 hours. So rather than, you know, rather than going to bed at 10 o'clock, you're going to bed at 12 o'clock. Or rather than going to bed at 12, you're going to bed at 2. So you're depriving yourself of some sleep there. So obviously, depending on how many hours I ask you to be sleep deprived, that will have a consequent effect on your academic performance, with the basic idea being that the more I asked you to be sleep deprived, or the more hours I asked you to be sleep deprived, the worse your academic performance is going to be, right? So by manipulating that IV, by manipulating or trying to change that amount of IV, which in this case is sleep deprivation, I am actually producing a change in the DV, which will be your academic performance. And so as a researcher, we have a lot of control over the IV and over how we can manipulate that IV. So how many hours I can make you be sleep deprived. Obviously, I have to think about ethical issues as well around that. So I can't tell you guys, okay, I want you to not sleep the whole night. That could be potentially harmful for you. Okay, so obviously, the main idea here is when we manipulate the IV, it always produces a change in the DV. Now, if you look at this example here, this middle picture, we've got a can of Coke and we've got a can of 7-Up, which is kind of like a lemony drink like Sprite or something. So if your study is if your study is assessing the effect of caffeine intake on the number of words you can recall from memory, obviously a lot of people think that caffeine does increase alertness, okay, and concentration. So in the experimental group, we're giving participants caffeine, yeah? But the control group, we're giving them a drink that doesn't have caffeine in it. And so what we would assume here is that the more Coca-Cola I give to a person, the better their number of words recalled might be, because more Coca-Cola means more caffeine, whereas the lemon drink doesn't have caffeine. And we'll talk about what a control group is very soon, but a control group is always used to measure the actual effect of the IV and the actual performance of the experimental group. So we'll talk about that in a little bit. Okay, so just to give you guys like a proper definition of IV and DV, or of cause and effect, The IV, which is our cause in our cause-effect relationship in experiments, is basically the variable that is manipulated or changed in some way by the experimenter to cause some change in the DV. So we cause some change in the IV, it will cause some change in the DV. That's just the pattern. So the dependent variable, in other words, then, is the DV. That's the effect part of the cause-effect relationship. So the dependent variable is the variable that is being measured for change. And obviously we call it the dependent variable because the DV depends on the IV, okay? How we manipulate or what kind of changes we make to the IV will produce some change in the DV. Okay, so what are we talking about here with these two photos? Well, a lot of the time, before we conduct a study, we might actually develop a research question. So if my research question is, does red cordial increase hyperactivity in children? I can actually look at that research question and take out the IV and DV from that. So when I say, does red cordial increase hyperactivity in children? Well, the IV is supposed to be the cause and the DV is supposed to be what I'm measuring for change. In most cases, when we look at behavior is always connected to the DV. So in this case, the behavior is not red cordial. Red cordial is just an item. The behavior we're measuring in this case is hyperactivity. Okay, so hyperactivity automatically becomes the DV because it is the variable or the behavior that we're measuring for some change there to see if it's increasing or decreasing. The variable that the researcher is then manipulating, which is supposed to cause some change in the DV, is the red cordial. So as a researcher, I can decide, okay, I want the kids in my study to drink 1 glass of red cordial, and then I'll measure their hyperactivity levels. Or I might get the children in my study to have 2 cups of red cordial, or maybe half a cup of red cordial, or maybe 1 liter of cordial. Okay, I can obviously decide as the researcher how much cordial I want to give these kids. Then how am I going to measure hyperactivity? Well, obviously I have to operationalize or measure that variable in some way as well. So I can't just ask the kids, how hyperactive do you feel? I might look at their behavior. So I might look at them, are they jumping up and down? Are they like a little bit jittery? Are they not focusing? Are they kind of like too stimulated in terms of being too active and, you know, walking around or running around everywhere? Those are some things I might use to operationalize or measure what that hyperactivity looks like, okay? And how I'm measuring that red cordial might be in terms of how many milliliters or how many glasses of red cordial I'm giving them. Okay, so that's basically the variables and a very general explanation of how we might measure or operationalize those variables there. Okay, so how are we going so far with this content? Is this too confusing, or is it making sense so far? If you've got any questions, you can just unmute yourself, or you can just put it in the chat box, okay? So operationalizing the IV and DV, like I just mentioned, it's talking about how we're going to measure the IV and DV. And so how we operationalize a variable is basically talking about, number one, what kind of test or measurement or tool are we going to use to assess that variable? Or number two, attaching a number or amount to that variable. So like I said in the previous slide, if I want to operationalize the IV or the independent variable of red cordial, I might attach a number to it. I might say, I'm giving my kids 200 milliliters of red cordial, or I'm giving my kids, sorry, not my kids, I'm giving my participants, my child participants, 250 mils of cordial, or I'm giving them 300 milliliters of cordial. Okay, if I was asking you guys to be sleep deprived in that previous example, I might ask you guys to be sleep deprived for 3 hours, or 4 hours, or 5 hours. Okay, so I'm putting a number to that. A lot of the time when we put a number to a variable, we are quantifying that variable, and we are actually successfully operationalizing that variable as a result. So what do we mean when we talk about this first dot point here, that we can also operationalize variables by stating the type of tool that we're going to use? Well, obviously, if I'm going to investigate the effect of, let's say, green tea consumption or weight loss, if my research question is, does regular green tea consumption result in weight loss for healthy adults, I might assess those healthy adults' weight loss by first of all looking at their original BMI before they had the green tea, and then after they had the green tea for a few months, looking at their after BMI. So before BMI, before the study, and then the after body mass index. Okay, and that's obviously a tool, or that's a number that I can use to measure that particular weight loss. Or I can even look at the kilograms. So how many kilograms they weighed before the study compared to how many kilograms they weighed after the study. Okay. can look at the waist circumference, so how much centimeters they've lost from their waist. Okay, so obviously there are many ways in which we can actually measure weight loss in general, and how we decide to measure that weight loss, or how we decide what tool we decide to use to measure that weight loss is another way we can operationalize that variable. Okay, so operationalizing sounds like a super difficult thing to understand, but simply it means how are we going to measure the IV and DV specifically. Okay, let's look at another example now. So let's say that we're testing the effect of meditation on sleep quality for year 10 students. Now, if we're looking at this particular research question here, so does meditation affect sleep quality for year 10 students? When we're trying to pick out the IV and DV, or in other words, I call them the simple IV and DV because they're not operationalized. We haven't talked about how these variables are going to be measured, right? So these are non-operationalized. So when we're trying to pick out the IV and DV from a research question, what we're trying to do is we are trying to look at, okay, what is the behavior that I'm measuring for change here? And number one, what is the cause? What's going to be the factor or the thing that causes that change in that behavior? So the behavior that I'm kind of measuring for change here, that I'm trying to see whether it's getting affected, is kind of sleep quality, if you think about it. Okay, so sleep quality becomes my DV. What is causing that effect in sleep quality or that change in sleep quality is going to be meditation. Because if I look at this research study here, I can make an assumption that the more a person meditates, maybe the better they'll sleep. Or the less a person meditates, maybe the sleep quality will be less as well. Okay, so you have to look at which variable is influencing that change and which variable is the actual behavior that's changing there. Okay, so the simple IV is meditation, simple DV is sleep quality. All right, so then if we look at operationalizing these variables, this is a slide where I really want to talk to you about what is the actual point of operationalizing variables. Okay, so if you think about it, you can have two researchers doing the same study, okay? And they can both tell you that researcher one might come up to you and say, yep, my study's on the effect of meditation on sleep quality. Researcher two comes up to you and says, yes, my study is also on the effect of meditation on sleep quality. But the way that they're measuring those variables might be different. So in researcher one study, he might be measuring meditation, but his participants only engage in half an hour of meditation per day for 3 weeks. Whereas in researcher two study, they are also engaging in meditation, but his participants might be engaging in meditation 3 times a week in 3 one-hour sessions for 1 month, which is a little bit more extensive and frequent, okay? Same thing with sleep quality. The way that sleep quality is measured or operationalized can be very different across two studies, even though those studies at first glance might look like they're assessing the same thing. So in researcher one study, he might be assessing sleep quality by asking the participant for a self-report. So give me a self-report of how you felt that your sleep was. And they might write like a report describing their quality of sleep. In a researcher two study, they might measure sleep quality by actually hooking the person up to like a little machine that actually tracks how much they move their muscles during sleep, okay? With the suggestion that the more they move their muscles or the more they kind of toss and turn during their sleep, the less quality that their sleep actually was. Okay, so obviously it's important for us to operationalize variables. And a lot of students always ask, even in year 12, oh my God, what's the point of operationalizing variables? It's such a drainer, it's so much extra words we got to write. Well, the reason is that obviously we do need to make our variables as specific as possible, okay? And we can have like a million different ways of measuring sleep quality, but we need to specify for our study which way we are actually measuring that variable. Okay, now a lot of the time you're not going to be asked to operationalize this yourself. If you get a scenario, it will already be operationalized for you. You just have to pick it out and say that, okay, this is how it was operationalized in the study. So you're not going to have to make it up. Yeah, in terms of SAC questions, but in your book, you might be asked to make some up just to show your knowledge of this topic. Okay, so that's basically operationalizing the IV and DV there. So now we come at looking at we've come to looking at how do we create a research hypothesis now? So we've already looked at this thing. We've looked at the fact that, meditation, we've looked at the fact that it can increase sleep quality in this study. So how are we going to create a hypothesis out of this? Now, if you remember correctly from a few slides back, our research hypothesis always contained 4 main key features there. So we've got our stating of the IV, we've got the stating or mention of the population, we operationalize the variables, so we mention or we explain how they've been measured, and we've stated the DV, okay? Now, this is a general formula that you can use to writing hypotheses, both this year and next year. We always start writing hypotheses with 4 words. It is hypothesize that. Regardless of what your hypothesis is, you always write this hypothesize that. You don't need to change that word hypothesize. You don't need to say it is predicted that, it is presumed that, it is thought that. No, just stick to the word hypothesize because it's the best word you can use. It is hypothesize that. The next thing you do is you add in or you insert your population in. So in this case, our population from a few slides back, if you remember, was year 10 students. So it is hypothesized that year 10 students, that's my population done. So what's the IV? Year 10 students who do meditation. Okay, meditation was my simple IV. Now, how are we operationalizing this in this study? Well, we're looking at researcher one's kind of study here. Whoops, sorry. So what we're saying is, meditation is measured by meditating for 30 minutes per day for 3 weeks. This is how we operationalized or measured this variable from the previous slide. So what effect is this going to have? We'll have improved, enhanced, or increased sleep quality. So you don't have to use all these words. Even if you just say we'll have increased sleep quality, that's fine. Okay. The main thing I wanted to point out here is that whenever you're writing a research hypothesis, you have to mention the direction of effect. Okay, the direction of effect means you have to put a descriptive word to it, like increased, decreased, lower, higher, because you need to show what effect is the meditation having. Is it creating better or higher sleep quality, or is it lowering the sleep quality? Is it increasing or is it decreasing? You've always got to use a descriptive word that suggests some kind of direction of effect there. And then we just operationalize the sleep quality as per the previous slide. So sleep quality as measured by self-report of the sleeper's experience of undisrupted continuous sleep. Then we mentioned the control group, and we haven't actually come to the control group yet. We're doing that in the next slide, but we have to mention the group that didn't need to go through the meditation, okay? Because in every experiment, we've got a group that always goes through the actual experimental treatment or the actual IV, which is the meditation in this case. But we also need a group of students or a group of year 10 kids who are actually not going to do meditation. This is what we call the control group, okay? We need the control group because they allow us to compare the results of the experimental group and to understand whether meditation actually had an effect on sleep quality as compared to a normal year 10 student who didn't engage in meditation, okay? So we have to mention the control group, and we do that by saying compared to year 10 students who did not engage in meditation. So that's basically what our research hypothesis looks like. So I know this can be a little bit confusing, but how are we going so far? Is everyone kind of okay so far?
Yeah.
Yeah? Okay. Again, this is a topic that we need to practice writing up. So you're not going to be able to write research hypotheses straight off the bat here. We will need to do our learning activities, and we'll practice this a lot more when we get back to school as well, with a lot of different other examples. Okay, so don't stress if you can't write a research hypothesis straight away. It's not easy. It will take time. And even when I was doing psychology, this was one of the difficult things as well to do. Okay, it will take time, it will take practice, but again, you've got a lot of time now, okay, to do that. So that's basically thing. And the last thing we're going to go through today is the experimental groups. Yes, the last thing we're going through today is the experimental group and control group. So I've already talked about what the control group is, but I want to explain it in a bit more depth now. So in a study, whenever we conduct an experiment, another key aspect of an experiment is that we need to have an experimental group and a control group. And I don't know, maybe you guys have come across these terms in science or in other VCE science subjects you're doing. The experimental group is the group in the study that actually do the task. So they're the ones that are exposed to the experimental condition. So they are exposed to the IV. So if we look at all the examples of the different studies that I've talked about today, okay, in that study where I was going to sleep deprive some of you and make you do a SAC, okay, the participants who are being sleep deprived are the experimental group, because they're the ones that are being exposed to the IV. The rest of the students in the class who I say, okay, guys, you don't need to be sleep deprived. You just continue your normal sleep patterns, but we're going to use you to compare the results of the experimental group. Those people who are sleep deprived are actually going to be my experimental group. The group that is not being sleep deprived will become my control group, because they're the group that are not exposed to the IV. That is, they are not exposed to the sleep deprivation. What was the other example? So the hyperactivity and the red cordial. Okay, if I'm looking at, okay, does red cordial increase hyperactivity in children? My experimental group are going to be the kids who actually drank the red cordial. Okay, they were the kids that were exposed to the IV, the red cordial. The control group are going to be the kids who are not drinking red cordial, or maybe they're drinking some neutral liquid like water or something that's not like got sugar in it. Okay. So the control group are the kids who are not exposed to the red cordial. That is, they don't drink anything at all, or they just drink water. All right. And what's another example I gave you guys? Oh yeah, the meditation and sleep quality. So obviously in that particular study, where does meditation increase sleep quality? My experimental group would be the year 10 students who actually did the meditation. They were exposed to the IV. My control group would be the year 10 students who were not exposed to the IV, so they didn't do the meditation at all. Okay. Now, as I said before, it's extremely important for us to have a control group. If you don't have a control group in your study, you can't conduct your study. And the reason for that is that when your experimental group participants actually come out with the results, who are you going to compare their results against? You don't have a baseline. You don't have a basic foundation there for comparison. So the control group needs to be there because we need to be able to compare the results of the experimental group to see if there was a change. Okay, so if we look at this study, this little photo here, and this photo is basically looking at, you know, does listening to music before sleep actually improve sleep quality? Okay, or allow you to sleep more, in other words. So if we're looking at this and we're saying, okay, does listening to music before sleep increase the amount of sleep you have? In the experimental group, you can see that they've got like music symbols above this girl's thing. She's got headphones on. That's the IV, okay, listening to music. Now, this is the experimental group because this person is listening to music, but then this person's also exercising. They're also eating healthy, okay? And they are sleeping continuously for 7.5 hours, which is quite a long time. Now we're looking at the control group. So the control group, she doesn't have earphones on her. There's no music there. So obviously she's not exposed to the IV there because she's the control group. But she's also eating healthy, exercising. So the same other factors are there. It's just the IV that's different, okay? So there's no other factor there that should explain any extra sleep except for the music. So obviously she also sleeps well. She sleeps continuously for 6.2 hours. But you can see that the people who listen to music still sleep slightly higher, for a slightly higher amount of time. Okay, so obviously when we're comparing experimental and control groups, we have to make sure that our participants are as alike as possible in other factors, and it's only the IV that is really differentiating what kind of sleep they might have. Okay. Okay, so yeah, basically, that's basically what we are looking at today. So we basically covered what I wanted to cover for today. So yeah, now I'm gonna give you guys a little bit, maybe 2 or 3 minutes. If you've got any questions, you can ask me. I know this topic is not super easy, but yeah, it's just about taking it one step at a time. So if you've got any questions, you can unmute yourself and ask me, or you can ask me through the chat box. I'll just give you like, I don't know, a few minutes to ask me that if you need to. Okay, I'm just going to go back a few slides because I want to bring up that due work slide again. Oh yeah, here we go. Okay, so yeah. Okay, so if you've got any questions, obviously you can ask me through the chat box, or when we move on to the school box class page, you can ask me on the social stream. I just want to point out that today you're not going to be working on all the learning activities, obviously. I will crop like what specific learning activities you need to do, and I'll post this on the social stream now. because you've only got to do the learning activities for the topics we've covered. I think it's up to 2.4, but again, I'll post the specific ones you need to do on the social stream. So for the rest of today, and in the next offline session, I want you guys to quickly finish off the few learning activities you've got. It's just 2 or 3 questions in each one, so it's super easy. And then I want you to use the rest of the time to work on your research project. Okay, so work on your research project and try to finish that off, because remember that is due tomorrow. Okay, and these learning activity, the whole list is due next Friday. So that's up to you how you want to use your time. You can work on your learning activity straight away, or you can just get started or finishing off your project. Okay, cool. So if no one has any other questions, I am happy for you guys to then move on to the school box and just begin your work. Okay, so either doing your learning activities or working on your research project, which is due tomorrow. And if you've got any questions, just put them up on the class page or send me an email. Okay, all good?
Yeah, bye, Miss.
Okay, bye-bye. See ya.
Bye, Miss.
Bye.